Beydoun. I'm CEO and co-founder of Wavve. We are a global team dealing with a global problem, and that is water contamination. At Wavve, we believe that clean, safe water is a fundamental right for every person around the world. That said, we produce a gel that is very efficient, biodegradable, cost-effective, removing harmful chemicals and heavy metals from water. So Wavve is initially targeting those two big groups of contaminants that I just talked about, and specifically aiming the high volume of water, low concentration of contaminant industry. That hits the municipal plants and the industrial plants. We're going to be more of a polishing stage than the first filtration stage in that whole industry. So this gel that I talked about is the only gel in the water filtration industry, and yes, noted, it's dangerous to be the only one in the market. But we've talked to a lot of people in the industry and really seen that nobody has seen a gel yet. Why is it a gel? It's because there's tiny beads, resin, ion exchange resin, basically, beads that we tried to make more and more efficient, and that got smaller and smaller, and actually technology became a gel. This technology is positively charged and attracts negative ions. So an example just behind with the cool ions is the nitrates. So we started this out and we saw that we had a lot of competitive advantages. The two main ones that are very different than any other kind of ion exchange resin there is biodegradable and cost effective. And those are the two big things we'll be focusing on in this presentation. So I did a quick market analysis of what's out there. Yes, your competitors are huge manufacturing companies. Where we're very different is we are the only one that is biodegradable, and because our raw material is different, our price can be lower. And this price here is in very large volume. We're talking about tons here. We tried buying 1 liter of Dow. It was $130 and not $9 to $15 just acquired. So this is how it works today in the industry. At the top, you'll see the raw material supplier that's acrylic plastic. And at the bottom, that's us, and that's how we do it differently. Our raw material is based of shrimp. We are a specialty material manufacturer, and we sell it to filter system manufacturers. And so also the cost goes with it. Knowing that we use a waste product from another industry as raw material, we are less expensive, I guess, to produce this gel than current materials. And so our price will also be less expensive for water filter manufacturers. This technology was invented at the University of Houston, and we have exclusive worldwide license rights to those two patents, formulation patents. By making those beads smaller and smaller and then becoming a gel, we now have a trade secret on the production of this gel. So we've been working on this for 2-3 years now. The two big main here companies we're dealing with are Veolia, the biggest water company in the world, that we just entered their first accelerator. And their goal is to find where we can fit in their company, knowing that we have the same vision of bringing sustainable technologies to the market. And Grupo Aguas de Valencia is in Spain, and they have 350 municipal plants and serving 3 million people. And so they're more interested in the removal of nitrates. But what we're doing right now is sending them material to implement a small pilot test in one of their facilities and really go from there. At the bottom, you'll see a lot of different logos. These are companies all across the board. This is when we were, I guess, in our search, where would we fit better? Oil and gas, removal of fluoride. We work in salt. So we tried a lot of stuff, and those companies helped us find the limits of our technologies and the potential. So to date, there's Dr. Enrico Nadras, who was the postdoc of the inventor, who was there since the beginning, the inception of the technology. He is the lead scientist and doing all the testing and the production to date. We have recently hired Pavan Raja, Dr. Pavan Raja, who is really working on the important milestones of 2016. There are scale-up, certification needs, and really flow rate, compaction of gel, all of those necessary testing from a chemical engineer. So that's what he's doing right now. And then myself and Yvette Rubio, who's the COO of this company, who have been on it for 3 years. We started at the university in the entrepreneurship program, graduated, and then stayed together the whole time through this fun journey. The advisory board, we have Dr. Deborah Rodriguez, who's the inventor, and also, I guess, the science advisor who really leads Dr. Enrico Nadras on, I guess, how to improve this gel. Michael Bridges, who has more than 25 years of experience in the water industry, he's a chemical engineer and has a lot of experience in scale-up. And Dwayne Dunk, known as the Water Guy, who's our market/business advisor for this company. Oops. Let me go back. I saw nobody put financials, so I don't know if that's good or bad. But anyways, my goal here is we want to try and hit $10 million in revenue in 2021. It's very hard with financials, and we all know it's a half bullshit, half art, and you never really know. But the important thing for me here is what markets will work first, and that's on sales volume. I didn't put that the actual volume that I'm going to be selling, and here I put a couple of municipal drinking plants and chrome plating plants only. And then we're seeking for a seed round to really scale up, like I said, acquire NSF certifications, and we want to hit first revenue in 2017. This is a bit of the past timeline. We've been through a couple of accelerators. We see great value from it, and I think you're all making a good decision here. The biggest value is the networking, and that's how we got our biggest potential customers. And we've got a couple of grants, and that's how we've been sustaining throughout the time. And our future timeline is so raising the seed round. We're applying for the NSF SBIR in June 2016 too. And acquire the NSF certification, production lab. We already know where it's going to be. We just need, I guess, the funding to really move everything over there. And scale production. Right now we're at 1 kilo per week. We want to scale it to 10 kilo per week for at least doing like big scale pilot testing. And 2017, hit revenue and just grow from there. And yeah, that's basically it. So once again, we're Wavve, and we produce a gel that is biodegradable, efficient, and cost-effective at removing harmful chemicals and heavy metals from water. Thank you. Yes. I'll just go.
So your raw material is ring, right?
One of the raw materials is a shrimp shell called chitin. Yeah.
Okay, gotcha.
That's what makes it biodegradable and different than any other resin in the market.
So is there any plans to get it from some? I mean, I thought that was the wasn't the shell, was the animal.
Mm-hmm.
So that may,
Yeah, it's just based of shrimp. That's what I say. But then we had the questions of, and that was a really good question at one conference. Was I'm allergic to shrimp. Can I drink your thing? No, it's from the shrimp shell. No worries, you don't have any allergies that comes with it. But that was a really good question. Yes.
So similarly, there's a lot of toxins and pathogens associated with shrimp waste. How are you going to convince customers that they're not going to get saxitoxin in with their water?
Yeah, I don't have to convince the customers. I'm convincing the municipal plants or the water filter manufacturers. So they're knowledgeable on chitin, the raw material we're using. Nobody ever had that concern to date, but I think it's a good point. I should probably look into it. Yes.
Can you talk a little bit more about how you compare with typical ion exchange resins that are regenerated?
Yeah.
You mentioned biodegradability. Is your material going to be disposed of, or will it be regenerated? How will it be used?
It depends on the two markets, I guess. And that's what we got a lot of critiques through the time where they said, hey, you have to pick one. And there's a reason we're still staying with two until one will officially close out. What happens with nitrates, they're interested in regeneration, but the competition can regenerate, I don't know, hundreds of times. We can regenerate 10 times today. That's just removal of nitrates, only municipal drinking plants. But the advantage is biodegradable. So now it's full of nitrates. I pass brine water, and nitrates. You can generally dispose of it in drainage, depending on the state. So that's easy. You can reuse it, and it's at the end you can use that gel in a sludge and just biodegrade it, or use it in the community around, and I guess use it as a fertilizer if it's full of nitrates. So there's a second use of it. Where it gets tricky, heavy metals, is we don't know which one's the exact, I guess, low-hanging fruit, because heavy metals now is regeneration is not interesting anymore, because what happens if I have brine water and selenium or chromium, I can't just dispose of it. So that becomes interesting. But there's not as many regulations because I'm not drinking that water. And so what we're doing right now, and we're specifically talking with a chrome plating company here in Houston, over there in Houston, is the fact that we're comparing our competitors in that industry are not ion exchange resins, are boiling people are boiling the water and then doing chrome cakes with it. And what happens is those chrome cakes, they still have a lot of water, so you press them, and then you have that problem of that water you have to dispose of, and everybody has an enormous fear of doing any kind of drainage permit or anything. So everybody's trying to reuse it, and so the gel might be an added point of safety, and so that's why we're really targeting the small chrome plating plants. The big ones have enormous methods that are completely different than ion exchange. For the small ones, they see an enormous value to it, and the fact that it's cost effective too might save them. And we went yesterday at the chrome plant, and we went through a cost analysis. And it was like, hey, listen, if you can you can probably remove $600 costs per week just by doing that. And we did a bit of the calculations. Yeah, it's going to be way less than that for us, and we can save them a lot of money. So, and there's no real certification needed for this kind of industrial needs.
Can this replace an existing product that's being used without retrofitting the plants?
Yeah, the only difference is, so I have some here. The gel is tiny beads, so you'll probably need the mesh at the bottom, but that's it. The water that flows through, then now we're hitting, a lot of people were interested in the flow rate. What happens to it, because the gel, the beads are smaller, you have less space for the water to pass through. So the cool thing about being the new product that nobody has used the gel is everybody's trying creative methods. So we have customers mixing it with activated carbon, like granular charcoal basically, in to space it out and have a better flow rate with it and add some removal capabilities with that charcoal. So there's a lot of different ways you can play around with it. That's why we had a big tagline, and I can't say it. I mean, it's basically, we used to say we don't make water filters, we make water filters better because we just enhance their systems. But we're opening now, we have a small 5-student team working on the B2C, residential, commercial. We see a need there. We were working with them on B2B. And what happened is they had no clue how to deal with the gel. So we were like, okay, let's calm down with this and let's do it ourselves, prove a market. So they're going to work on a smaller thing, and they're going to basically use shrimp. And instead of using activated carbon, normal one, they're going to use coconut shells. So we're going to have coconut and shrimp and create a house filter for it. Their only goal for the summer or for the whole year is to see if the end consumer actually cares that it's biodegradable and coconut shrimp. Yes.
From a pure supply chain perspective, is there enough shells to satisfy your needs?
Yeah, chitosan is already used a lot in the industry. I think we saw it in heart surgery. A lot of people use that gel. Not our gel, but another kind of gel with chitosan and other polymers. So yeah, I'm not worried about the supply of it, and the cost being so low. I don't think I'm not worried about that raw material. I'm more worried about our polymer or something like that than the chitosan itself. And just FYI, we can change chitosan. This is shrimp one, but there's I never know how to say it in English, but any kind of water mammal that has a shell or something like that. Yeah, exactly. I can't say it. It can be chitosan. Could be another source, so we didn't do all the testing on it yet.
Yeah, insects too. Same thing.
Probably.
Yeah, like grasshoppers.
I don't know if I want to sell something. I know that we're trying to eat them now, so I don't want to be the first person to try and say, I'll stick with shrimp first, and then once it's like more into it, yeah, it's a good research on it. Yeah.
I think the pathogen question is something that you guys should think about, what Dr. Ellison mentioned at the beginning.
Yeah, I mean, that's a good point.
Coming back to removal rates and competing with existing media, how do you compare there against activated carbon or some of the other things that you want to displace?
So activated carbon doesn't remove harmful contaminants. They say they do some, but they have no certification for it, so that means they don't. That's just, and Brita is the best marketer in the world. We clearly hands off to them because they say they make your water taste better, and they do, but they don't make your water safer. That's why Flint, Michigan is not saved by Brita. And what happens is we're different. We remove other types of contaminants that are negative ions. And there's ion exchange resins that are really good. Some of them are even better than us, but are different. So we're not really saying, hey Dow, you have 1,000 different resins, and we're going to beat you on 1,000. No, we're going to pick one, and we're going to beat you on that one, and we're going to specifically choose that specific war, basically, or buy us out, and then we'll see.
All right. Thank you, Eric.